Hello, my name is Evan Hassman, and in this video I'll be talking about my age, sex, and emotion identification machine learning model that is run on Android for my ECE 528 project. For this project, I wanted to create something that would be challenging and something that could provide lots of learning experience for me. Specifically, I wanted to work on Android because I've never used it before, and it also has lots of potentially challenging hardware and security restrictions. I also wanted to work with multiple one network that would be able to run two outputs at once, and another network to run concurrently. The end goal ended up being an app that would run on Android that would use its two networks simultaneously. It would be run on a budget smartphone. One network would determine your age and sex. It would be trained on the UTK face dataset of 48 by 48 grayscale images. And the other network would determine your current emotion, trained on the AffectNet dataset that contained various size images. There were lots of technical challenges in that I had a lack of experience. Specifically, I'd never developed an app on Android before, so I would need to learn how to use the Android Studio. I've also never seen a machine learning model that could run two outputs at the same time, and running two machine learnings on such a budget device could be potentially problematic. There was also a issue with the formatted data from the AffectNet dataset, as it came with multiple extra annotations, and I would need to reformat all 300,000 images and labels before being able to use it. There's a couple of related works that I would like to talk about first, specifically the analytics video, which was a article that I started with. It ended up being a bad example of using models to calculate age and sex from an image because it had lots of errors. It also had seemingly fake results, but it was a very good starting point for this project. I also found a Towards Data Science article that was a good example of using machine learning to detect emotion, but it used a different data set, image resolution, and different categories of emotions. Finally, I had this YouTube video that showed an example of how to make an Android app that could run a TensorFlow model, which ended up being very helpful. The first thing I needed to do was modify the dataset. The AffectNet dataset came with lots of extraneous files, including valence, arousal, and landmark face locations. So first I needed to remove those. After filtering them out, I was able to sort the files by name, length, and numerically to match the image files to the NumPy files. Then I would transform the images into 48 by 48 grayscale images and list all pixels as a string before reading all the NumPy files and placing their content into a list. Finally, I would append a header to the CSV file and save the to list on it. To create the models, I started with the age and sex model. This had 4 layers of 2D convolution before it separated into 2 unconnected dense layers. The 2 dense layers would connect to output layers, one for age and one for sex, and the emotion model was created on 3 layers of 2D convolution, 1 dense layer and 1 output layer. The next part of the project was creating the app itself. The layout included one button that would open up the camera and allow you to take the photo. The photo would then be displayed in the image view in the center of the screen, and it included 4 text views to display the classified as text as well as the results for the model. The functionality was written on a JavaScript that would take the images and set them into a byte buffer that would then be able to be resized into the 48 by 48 grayscale images that are required for the models. It would then feed them into the models directly before updating the results with the 3 designated text views. This app layout was heavily influenced by the YouTube video that I had mentioned previously. The final results can be seen on the right here. It does include all 4 text views, the button, and the image view. The models had relatively alright accuracies. The age had a 4.8% accuracy when guessing the age exactly, around a 43% accuracy when guessing in age groups. The sex had an 86% accuracy, and the emotion had a 40% accuracy. This app was primarily developed to be a learning experience for me, and as such, it was very impactful for me, but I have doubts that it would be impactful for anybody else that was not along for the journey. That being said, I would like to expand upon this project. For future work, I would like to add a audio processing machine learning model, something that could take maybe a 5 or 10-second video and determine your age, sex, and emotion from that would be very interesting. I also would like to work more with continuous images. I did have a previous version of this app that could support that. However, after finding the hardware limitation would render less than 1 image per second, it would also create very blurry images that were not very accurate, and as such I decided to scrap that. The last thing I would like to add is a more accurate emotion and face position. The current app has issues in that if your face is not directly in the center and not squared, it will throw very bad results, and as such I would like to continue to work to attempt to solve that issue. Thank you very much.